Okay, so there are two formulas we're going to use in terms of compounding interest. So in here, we're going to focus on compounding interest. Now, if you open a savings account and the bank only pays you interest once a year, that's not compound interest. That is called simple interest. Most banks don't do that. So if it's only once a year, it's what kind of interest? Simple interest. If it's more than one time a year, then it's called compound interest. So next time you're at the bank, ask them whether they use simple interest or compound interest. If it's compound, ask them how many times a year. Or you probably don't want to know that. You don't care. All right, compound interest. All right, so when we talk about those formulas, there are different words you need to know. You could be compounding monthly. And I'm going to use the letter N, because you remember in that formula we were using earlier, that expression, this expression here, if I can find it, this expression here, what was my variable? N, and N represented time here. So I'm going to use N. So that's the number of times, guys, that's the number of times it's being compounded. So if your interest is being compounded monthly, that means how many times a year? 12. So N is 12. N is the number of times interest is compounded a year. If they tell you it's daily, let's assume it's not a leap year. How many days are there in a year? 365. If it's quarterly, 4 times a year. Every 3 months, how many months are there in a year? 12. How many groups of threes are there? 4. So N is 4. And the other one you need to be familiar with is semi-annually. What's semi-annually? Twice. I think those are the only 4 you need. So monthly, N is what? 12. Daily, N is 365. Quarterly, N is 4. And semi-annually, N is 2. Semi-annually means every 6 months. So 2. Okay, so there are 2 formulas. You don't have to know those formulas. I'll give them to you. You just need to know when to use it. So the first one is this. A equals P times 1 plus R over N raised to the NT. A equals P times 1 plus R over N raised to the NT. Now, part of that expression should look familiar. Remember when we let N get bigger and bigger and bigger and bigger? That 1 plus over N to the N? It was actually 1 over N. 1 plus 1 over N raised to the N. So part of the expression should look familiar. The other formula is this one. So those are the 2 formulas you're going to use for compound interest. These are the 2 formulas you will use for compound interest. Now, depending on how many times you're told is being compounded will determine which one you use. Listen carefully. The A stands for the amount you end up with. So the ending amount. So A stands for amount. P stands for the principal. P stands for the principal. P-A-L, not P-L-E, P-A-L. Principal. So principal is how much you put into the bank. So you go to the bank, you open a savings account, I put in $1,000. What's my principal? 1,000. Okay? 1,000. So that's how much you initially invest. How much you initially invest. What do you think T stands for? Time. T is time. And time must be in years. T is time, and time has to be in years. All the ones we're going to do, it's not going to be difficult. All the ones we're going to do, the time will be in years. It was must, so just listen carefully. Suppose I'm not going to, and then I could do it in my math lab, but if you're told that time is 6 months, then what's T? 1/2. 6 divided by 12. Remember, I told you time has to be in what unit? Years. So if I'm only in there for 6 months, then I'm in there for half a year, right? 6 divided by 12. Right, so 1/2. So T would be 1/2. All right, N, see these N's up here? N is how many times a year is being compounded. So N is number of compoundings. N is number of compoundings. R is the interest rate. R is the interest rate. So for example, now you have to remember some things from a previous course. So if I tell you that the interest rate, is 6%, then you got to write it as a decimal. What 6% is a decimal? 0.06. Okay. So you don't put the 6 as R, you got to rewrite as a decimal. So you learned about percents in maybe 3 courses ago. And it's also one that you learned when you were not 6 months, but maybe 8 months. All right, 0.06. So remember, you move the decimal point how many places to the left? 2, because percent means divide by what? 100. That's what percent is, divide by 100. All right, now, which formula don't you see the N in? The second one. Now, it's easy to remember, but I'll give you the formula, but if you are not given the formula, it's easy to remember that formula. The shampoo. Hurt. P-E-R-T. So there's no N there. There's no N there. Nope. No. When we were talking about E, listen carefully to this, guys. When we were talking about E, I said this. I said as N gets bigger and bigger and bigger and bigger, this expression gets closer and closer to what number? E. So when I say bigger and bigger and bigger and bigger, we said as n gets closer, as n goes to infinity, this expression gets close to what number? E. So n, the number of compoundings, is not finite. If n was quarterly, that's n equal what? 4. If it's being compounded monthly, n is what? 12. If it's being compounded infinitely, infinitely. Remember, finite you can count, right? N is 2, n is 4, n is 12, n is 365, and so on. But can you tell me finitely what this infinity is? No. So we said as n goes to infinity, this expression goes to what? E. And that is what you're going to use if the number of compoundings, if you're told that the number of compoundings is compounded continuously. So you're going to use this if interest is compounded not finitely, but infinitely. And what's the word we use for infinitely? Compounded what? Continuously. Continuously. Those are two formulas. It is easy. I know we went through a lot here, but it's easy to know which one to use. If it's compounded quarterly, which one do I use? First or second? First, because n would be what quarterly? 4. If it's being compounded daily, which one do I use? First, because there's an n. What's n? 365. If it's being compounded semi-annually, what's n? 2. And which one would I use? First. If you're told that is being compounded continuously, meaning infinite number of times, the second. All right? Okay, so let's do some problems. You're going to see how easy this is. Almost all students can get this on a test. If you know how to use your calculator, by the way. You got to know how to use your calculator. All right, the first one. A newborn child receives a 20,000 gift. I wish I had that. I wouldn't mind being newborn again if I could get this. A newborn child receives a 20,000 gift towards college education from her grandparents. How much will the $20,000 be worth in 17 years if invested at 7% and compounded quarterly? All right, so first of all, you got to determine what? Which formula? So which one do I use? The one that has n in it, right? Okay, so I'm going to have to use this formula. A equals P times 1 plus R over N raised to the NT. That's what I'm going to use. So right off to the side, what those values will be for the unknowns. No, you're trying to find A, right? Yeah. You're trying to find A because it says this. How much will this $20,000 be worth? So what amount will that $20,000 become? What does that $20,000 represent? P, the original amount, the initial amount invested. So P is $20,000. What does the 17 represent? So which variable? No, not N, T. Remember, T is time. And time must be in what unit? Years. So T is 17. What is R? Which is 0.07. Remember, you've got to rewrite that 7% as a decimal without the percent symbol. And what is n? 4. Quarterly. It's being compounded quarterly, so n is how many times being compounded per year? So n is 4. And you take this, plug it back into here. So all I need to see the substitutions, by the way. So I need to see this. I need to see A equals 20,000 times 1 plus R. What's R? Divided by 4. All raised to the, now put that in parentheses because nt is a product. On the calculator, that's going to matter. You got, when putting this into your calculator, listen to me, when putting this in calculator, that exponent n times t has to be in parentheses. Otherwise, you're not going to get the right answer.
Round it up to the nearest penny.
Nearest, you always round off nearest cent. Yeah. So what's n?
4.
And what's t?
17.
All right, so that's 4 times 17. Okay, so on your calculator, do this. It's very simple. Just watch. You just, on this particular calculator, now remember, you got to know how to use your own calculator. If you have a calculator where you have to do things in opposite of what you see, you may want to invest into a different one. You want a calculator where you can type in what you see as you go. So what's the first thing I see? 20,000. What's the next thing I see? Which is really what operation right here? Multiplication. So P times. All right. And then what's the next thing I type in? 1. What's the next thing I type in? Plus. Just tell me what it is. So what's the numerator? 0.07 divided by 4 in the parentheses. Then I got to raise. So that's this right here, that power. And then in parentheses, 4 times 17, close, press equal, and this is what you see. We're dealing with money. That's 17 years for $20,000 though. And also keep in mind, how many savings account has interest rate 7%? Hardly any. You're talking about maybe 1%, 1.2% maybe. Now, way back then in the 70s, it was up there. So how much money will this 17-year-old have?
$65,068.44.
So A equals?
60. So A equals 65,068.44. So always, when you deal with money, always round off to the nearest cent. Nearest cent means nearest hundred. Like you do with your own money, $2.25, $2.38. All right. It's just plugging in and knowing how to use your calculator. All right. Let's do 2A.
I'm not, let's go to, I'm not getting something right.
What aren't you getting?
20,000 parentheses 1
Plus 0.07 divided by 4, close parentheses, raise, parentheses, 4 times 17, close.
Oh, okay, that's what I did do right.
Okay, so notice he did not put, what he probably put was this. He put raised to the 4th, then times 17.
But I'll put the 17 in parentheses, like to make like a multiplication.
No, you got to put 4 times 17. Because even if you put 4 parentheses times 17 parentheses, that's still not the same problem anymore. Because all you're doing is raising this to the 4th. This is what you're doing. You're raising this to the 4th. Whatever that is, you're multiplying by 17. That's not what this says. Okay. All right. 2A. Which formula do I use? The one with the n or the one that's being compounded continuously? The one with the n, 2A, is being compounded monthly. You use PERT if it says it's being compounded what? Continuously. Okay? All right, so I still use the same formula. A equals P times 1 plus r over n raised to the nt. What does that $10,000 represent?
Principal,
Principal. What does the 9% represent?
0.09,
Yeah, that's,
interest,
yeah, that's, so that's your rate, right? But that's not really what, if you open a savings account, that's not what you're going to get.
it sure would be nice, though.
All right. What is in
12,
12? And what's the time? Yeah. Now here's why you might say, well, there's no time listed. Okay, listen to me. They're asking you an A and B. They're saying, which would be a better investment? 9% compounded monthly or 9.3% compounded annually? All right. So since they're just asking which one's going to be the better investment, it really does not matter what T is. But whatever you use, you better use it in both of them because you're comparing the two. Is that clear? So we'll just let T be 1. T be 1. So let T be 1. You do it in both cases, all right? Okay, so let's see which one's going to be the better investment. All right, so A equals P. What's P? 10,000 times 1 plus R. What's R? Divided by 12 raised to the N times T. What? Now you see that 12 times 1? That's just what? 12. So when you use your calculator, do you need to put that NT in parentheses anymore for this one? No, because it's just 12. So it just raises the 12th power. All right, use your calculator. Tell me what this is. So 10,000. Make sure you can use your calculator, guys.
$10,938.07.
$10,938 and what?
7 cents.
Is that what y'all got? All right. So in 1 year's time, my $10,000 would become $10,938.07. I'm just curious, though. What's the increase? I started with 10,000. What did I end up with?
900.
No, I ended up with 10,938.07, right? But it increased $938.07. What is that 900 some odd dollars? Your interest. Your interest. That's a lot of interest on $10,000 for 1 year. But that's because it's what interest rate? 9. So that $938 is your interest. All right, let's do the next one. This time, again, P is $10,000, your initial investment, times 1 plus R. This time, what is R? What is R this time? 0.093, good. What is N this time? 1. Annually is 1. Raised to the N. What's N? 1. What's T? 1 to the first. Now that is the simple interest, by the way, because how many times being compounded a year? 1. That's simple interest. All right, so basically all you do is this. It's 10,000 times 1 plus 0.093. Because the exponent is what?
1.
Don't waste your time raising the first power, because anything raises its first power is what you have in that parentheses. So tell me what you get.
10,930.
How many? Exactly 30?
Nothing, no cents.
0. Not by much, but which one is the better investment?
First one.
First one. I'm going to ask you this, and it's really important. It's not about much, right? Maybe $2 more?
$8 more.
Oh, $8. You're right, $8 more.
$8.
So it's not much, $8, right? Why is it, I'm asking this question, listen carefully. Why is it, the rates are almost the same, so that's negligible. But why is it that the first one, you are getting more money than the second one?
Because it's compounding.
Compounding.
So you get
Remember I told
interest
you
on
that, that compound interest is where interest is earning interest? That second one, it only occurred how many times? One time. The part A occurred how many times? Interest is earning interest in itself how many times? 12. So the more times you compound interest, the more money you get. So that's why you hope your bank is compounding interest what?
Daily?
No.
Or continuously?
Continuously.
Yeah.
Continuously. So the better investment would be part A. Part A is the better investment. So this is your better investment. All right, let's skip 3 for right now because on your worksheet it doesn't have anything to do with 3 just yet. We'll come back and do 3 Monday. Let's see what else we can do. Okay, let's do 4. Let's do 4. We'll come back and do 3. Let's do 4. At age 27, Jill deposited $4,000 into an IRA where it earns 9.8% interest compounded monthly. What will it be worth when she is 35? No. You use PERT only if you see what words, guys?
Continuously.
Compounded continuously. I didn't see the word continuously at all.
This does not. Compounded monthly.
Must be 12.
Okay? All right, so I'm going to use the formula A equals P times 1 plus R over N raised to the NT. What is my initial investment? 4,000. What is my rate? What is your N? What is N?
12.
12. All right, now the time.
8.
Why 8?
Because 8 years.
Right, she's 27 now. She wants to keep it in there until she's 35. So how many years is that? 8. Right. So you just plug and chug. So A equals P, 4,000, times 1 plus R, what's R?
0.098.
Divided by
12.
12, raised to the
12.
12 times
8.
8. All right, now make sure you put this in your calculator correctly. Use your calculator. Take your calculator out and make sure you know how to use it. So if you're doing it correctly,
Yeah.
you have 4,000 times 1 plus 0.098 divided by 12, close the parentheses, raise it to parentheses 12 times 8, close. If you did it correctly, you should get $87,330 and 12.
No, it's $8,733.01.
What did I do?
I'm going to that bank.
Yeah, you're right. So here's the other thing I would tell you if you wrote this down. I'd say, do you think it makes any sense? You start with 4,000, you end up with 87,000? No, something's wrong. So let me go back and do this again. 4,000 times, in parentheses, 1 plus 0.098 divided by 12, close the parentheses, raised to 12 times 8, right? Close the parentheses, press equal. Oh, 8,000.
Yeah, $8,733.01.
So 1 cent, right? All right, so I'm not sure what I did to get that other. Maybe I put, instead of 4,000, I put 40,000. I don't know.
It happens.
All right, okay? Now, so the $4,000 will be worth how much? $8,733.01. Turn it back. Okay, let's go ahead and, because someone kept wanting to do the PERT formula, it's not on here, so let's go ahead and, let's go ahead and do number 5. Let's do number 5, and let's make it compounded continuously. All right, so listen to me. Here's what you would have to change. So you need principal, right? What's my principal?
3,500.
3,500. You need T. What's T?
10 years.
10. You need R. What's R?
5.3%. Well,
It's 0.053. You don't need what letter? N. So that means instead of saying compounded daily, I need to say compounded what? Continuously. So let's change it to that. All right, so let's plug into PERT now, because you see what word? Continuously. So A equals P times E to the RT. All right, what's P?
3,500.
Times E in parentheses, put RT in parentheses now. What's R? 0.053 times T, what's T? T, 10, close the parentheses. Now make sure you know how to use your calculator. Now again, always make sure you put that exponent RT in parentheses when using your calculator. So 35,000 times E, you gotta get that E. How do I get that E here? Times second ln. So you get that E to the X. And what's that exponent? 0.053 times 10, close, press equal, and $3,500 in 10 years at 5.3% compounded continuously is $5,946.26. All right?
Not as good as the others because it's only being 5%.
Right, your principal is also very low.
Yeah.
Now, for most of us, having $3,500 would be a godsend.
Tell me about it.
Okay. All right. So we're gonna do a couple more with this Monday, because I do want to come back and do number 3. I want to come back and do number 3. So do a couple more Monday, but guys, all you need to know the formulas and how to use it. That's it. So those are easy points to get on a test.